I swear to God, if I moved to walk.
What's that? All right. Oh, there's you on the video. This is page 5. It says page 6 on mine. It's page 5 of your notes in the middle. And these are redox in acidic solution. Redox in acidic solution. So I will tell you they're in acidic solution or basic solution. If it's in acidic solution, that means there's excess what? So what do acids have in them? So if it's in acidic solution, we have some excess hydrogen floating around. If it's in basic solution, there's some excess OH negatives floating around. Okay, it's in one or the other. I will always tell you that. There's also water because it's involved in aqueous solution. Here's why the acidic and basic matters. You used to have to memorize some of this stuff, but this ion changes into this ion in acidic solution. In basic solution, it changes into MnO2. It doesn't get oxidized or reduced the same way. Not that you need to memorize that, but things change a little bit in that regard. All right. Here's what you got to do. First of all, figure out what's oxidized, what's reduced. So that should be fairly easy to do at this point in time. What's oxidized, what's reduced. So figure out individual charges on atoms. Remember this ion, this permanganate ion, is probably like potassium permanganate or sodium permanganate. So oxygen's charge, -2 times 4 would be a -8. This whole thing has a -1, so what is manganese? Positive 7. Let's just go over here and figure out manganese's charge over here. Pretty hard to figure out on this side. Okay. +2. I like that. So is that up or down? That's down. That's reduced. Charge is going down by 5. Iron's pretty tough to figure out too. +2, +3. So it's going up. Okay, so it's oxidized. So we're going to write half reactions like we did yesterday. We're going to do a reduction half reaction and an oxidation half reaction. And then we'll combine them into one total reaction. So reduction, oxidation. I tend to do reduction first. It makes no difference which one you do first. Remember, oil rig, reduction is gaining electrons. Reduction is gaining electrons. As you're doing this, you have to write down the whole polyatomic ion that your element is in. So that manganese is in this polyatomic ion. You got to use that whole polyatomic ion. So our reduction half reaction is MnO4 with a negative charge. Don't forget charges on things. Going to, and I leave some space here, going to Mn +2. So this is your reduction half reaction. And your charges. So the first thing is we have to make sure that we have the same number of manganeses, not oxygens, but the element being reduced. Well, there's one manganese, so we're good there. +7 charge to +2 charge. So we're looking at the individual manganese charge. How's it go down by 5? Gains 5 electrons. So we put +5 electrons on this side. The electrons are taking care of the oxidation reduction. All right. Is everything equal? Is our overall charge equal? No, and our number of oxygens isn't equal, right? So we got to get those equal. Okay, so this overall charge is a -1 and a -5 is -6 on this side. So when I say overall charge, not individual atom charge, this ion and this is a -6. And that's a +2. They don't need to cancel, they need to be equal. I need equal charges on this side and this side is supposed to be 2. Sorry. Now, I can add in hydrogens because we're in acidic solution. So I can add in hydrogens because we're in acidic solution. So how many hydrogens do I need to add? 8 to the left side. There's probably an easier way to do that actually. Sometimes it's hard to figure out those charges. We're also going to add in waters to equal out our hydrogens and our oxygen. You can sometimes add in the water first. So think about it. There were 4 oxygens here. How many waters would you need to make 4 oxygens? 4 waters have 4 oxygens in them. So if I see those 4 oxygens, a lot of times I'll just go over and go, okay, I know I needed 4 waters to equal out my oxygens. Well, how many hydrogens does that just give us? 8. We know there's 8 hydrogens over there. But our charge should be equal. People get confused on that. Not individual atom charge, but overall molecular charge should equal on both sides, +2 and +2. All right, we're good there. Oxidation is going to be a lot easier, and here's how I know that. There's no oxygens involved. Whenever there's no oxygens involved, it's really easy. It means we're not using hydrogens or oxygen or water, sorry. So our oxidation half reaction would be Fe plus 2 going to Fe plus 3. And oxidation is losing oil. Oxidation is losing. So this is going from +2 to +3. Lost how many electrons? Lost 1 electron. But remember, instead of writing minus 1 electron over here, we add it to the other side. So we put plus 1 electron on that side. All right. That's all we had to do in the bottom. Pretty simple. Now we just need to combine these into one equation. Remember, your electrons are lost down here need to be equal to your electrons gained here. And so electrons are being given from that to that. So what do we need to multiply the bottom one by? 5. 5. 5. 5. 5 electrons are being gained by manganese. 5 electrons are being lost by iron. Actually, 1 electron per iron, but 5 iron atoms are doing that. We can cancel electrons. 5 electrons are being used, 5 being produced. We're done. There's our net. Now you just combine it into one. So here's your reactants. You have MnO4 negative plus 8 H pluses plus 5 Fe plus 2s. Make 1 Mn plus 2, 4 waters, and 5 Fe plus 3s. So that's good. I'm about 175th in the world right now. All right, here we go. This is called a dichromate ion. Again, it'd be like potassium dichromate. Is that an acid or base? Acid. Okay, this is in acidic solution. I would tell you that always, but we are in acidic solution, so it is acidic. All the ones we're going to do right now are in acidic solution. I don't know what that is, or I just did, but we'll go with it. So let's figure out individual charges first. Oxygen here would be a negative 14 overall. That means our chromium must be a total of what? Positive 12, because that ion has a negative 2 charge. So what is each individual chromium atom's charge? Each one is a +6 individually. I'm pretty sure chromium's charge over here is a +3. Okay, so is that going up or down? Down. So that's reduced. What element do you suppose is oxidized here if you just had to take a guess? Sulfate? Sulfur. Yeah, probably sulfur, because hydrogen and oxygen charges don't tend to change a whole lot. So let's figure out what sulfur charge is. Oxygen here would be -6 total. Hydrogen would be +2 total. Our sulfur is a +4. Let's figure out sulfur's charge over here. Oxygen's a -8. And the whole thing has a -2 charge. So sulfur is a +6. So it's going up. That's good. Chromium going down, it's reduced. Sulfur is going up, being oxidized. All right. So 2 half reactions. I tend to do reduction first. You can do whatever you want to do. It makes no difference at all. Remember, reduction is gaining electrons. So remember, you have to write the whole ion. People sometimes just want to put just the chromium in it. You got to write whatever it's a part of too. So Cr2O7, -2. Leave some space, going to Cr +3. There's probably the thing that people make maybe the most mistake on when these get like this. Before I do my electrons, I got to make sure my atom being reduced is equal. Is it? I've got 2 chromiums here and only 1 here, so I got to put a 2 in front of that, which is going to do what to my electrons? Double them. So that's it's easy to mess that up a little bit. Easy to mess that up. So, erase all this junk. So chromium was going from a +6 to a +3 individually. So I would be gaining 3 electrons. but now we have 2 of them doing that. So 6 electrons. So overall, this chromium is gaining 6 electrons. These 2 chromiums are gaining 6 electrons overall. So plus 6 electrons. Remember, the electrons are just getting your reduction or oxidation. Now we do hydrogens and water. Hydrogen, water. I'll tell you, I've usually taught to do hydrogens first, but probably easier to do water first. You got 7 oxygens here. So we're going to need 7 waters over here. Now, how many hydrogens does that just give us? 14. So we're going to need 14 hydrogens over here. Because we're in a acidic solution, we can add those in. Let's make sure our charge is equal. And not individual atom charge, but overall. So this thing is a -2, a -6, and a +14. What's the overall over that side? +6 total on that side. +3 times 2. +6. The other mistake people make is they want to make those cancel. Like they want this to be -6, that to be +6. You want them to be equal. Okay, charge is equal. All right. There's your reduction, oxidation. Let's go with a little blue. Good with that? Oxidation. So we have to write this whole thing, not just the sulfur atom. We write the whole thing that's a part of H2SO3. That is a weak acid. That's why it's together, not split apart. It's a weak acid. I try to keep my arrows in line. That way I can tell my reactants and products. Forms SO4, -2. Make sure your atom is equal that's being oxidized. 1 sulfur, 1 sulfur. Don't worry about the hydrogens and oxygens. You'll get those with hydrogen and water. Sulfur is going from +4 to +6. So how many electrons is that? 2. It's losing 2 electrons. So instead of -2 electrons, we write +2 electrons over here. I don't like having these charges here because they confuse me sometimes. So I'm getting rid of them. Yes. Now what? Want to do water first? We're going to do water. 3 oxygens, 4 oxygens. We need 1 more oxygen on this side. So put in 1 water. How many hydrogens are over here? 4 of them. Be careful, they're in 2 spots. So we need 4 hydrogens over here to equal that out. And that should equal out our charge. If it doesn't, then we got to do something different. So charge over here, this is neutral and that's neutral. So this side's neutral. -2, -2 is -4, +4, this side's neutral. So we're good. We're good. All right, electrons that are lost over here have to be equal to electrons gained here. Remember, in this case, sulfur is giving electrons to chromium. It's giving electrons to chromium. Well, we have 6 and 2, so we're going to multiply the bottom one by 3. Bottom one by 3. So this becomes a 3, a 3, a 3, a 6, and a 12. All right, we're getting closer. We're almost done. Now we combine it. My video's going to go over 15 minutes if I don't get done here. I can't put it on YouTube. This is your net. Okay, so I'm going to draw a little line right here just so I know this is my reactants, there's my products. 6 electrons being used, 6 being produced. What's the net? There you go, right? And get rid of them. 14 hydrogens being used and 12 being produced. So your net is that 2 were used, right? So we're going to just say, okay, that's gone. The net here is that 2 of them are on the reactant side being used. Anything else that you can cancel? 3 waters over here being used, 7 being made. So our net would be 4 on this side. Yeah.
What about the H2O in the equation?
I have no idea why that's in there. I don't know. Don't worry about it.
Okay.
Okay, we'll put our own waters in. I don't know why that is. It's a really good question. Now we can write our overall reaction, which would be 1 of these with 2 hydrogens plus 3 of those makes 2 Cr plus 3s plus 4 waters plus 3 SO4 -2s. I'm going to stop my video before it goes over 15 minutes. Have a good day.